Hello everyone, today we're doing GCSE Maths Practice Test Set 9, Paper 1H. So let's get straight into it. This is a non-calculator, so don't need a calculator. So let's go to the first question. Here is the hexagon ABCDEF. CD is parallel to AF. Work out the area of hexagon ABCDEF. Now this question does not require any specific formula, okay? Now it looks really scary because it's a 4-mark question on the first question, and if you're on the exam, I know this is practice paper, but if you're on the exam, you'd probably be panicking, It's probably like, whoa, this jumps difficulty. So let me show you how to do it. So we're trying to find the area of the hexagon, and we have this shape. So notice if we draw a line across, it's parallel. Remember, it's parallel to AF, and it will be parallel to CD. And because these are the same line, because we've just moved AF just a bit up, okay? This will also be 20 centimeters. Okay. Next, the whole height of this shape is 24 centimeters, and the height of this line is 14 centimeters. So over here, this would be 10 centimeters. So now we have split this confusing shape into two different shapes, and we can find the areas separately. So let's start with this trapezium. So we have 16, 20, and we have a perpendicular height of 10 centimeters. The area of a trapezium equals 1/2 a plus b h. Now h is the height and a plus b are the two parallel sides. So let's plug this in. 1/2 of 16 plus 20 times by 10. We get 36 over 2 times by 10, which would be 18 times 10, so that's 180. Next, let's figure out the area of this bottom rectangle. We have 14 and we have 20 here. Area of a rectangle is just base times height. Then we can do that. 14 times 20 is 14 times 10, which is 140, times by 2, which is 280. So 280 plus 180 equals 460, which is our final answer. Next, we want to reflect triangle S in the line y equals x. Label the new triangle capital R. Okay, let's do that. So the line y equals x, what you would do, let's plot this. So when x is 1, y is the same. So we just plot there. And you'll notice it's just this diagonal. In GCSE, they won't ask you anything more complex than just the diagonal, okay? So it's kind of good if you know. So I'm going to join the points up now. Hopefully doing a good job just joining them up. It's a bit wonky, but the premise will stay. So let's flip this across. So imagine you put a mirror along that line. Where would the new shape be? So we have this shape here. So that'll be the new dot. We have it from one diagonal here, so it'll be one diagonal there. And you can see it will just form the triangle here to get shape R. I hope you can see how it's reflected along this line. Obviously the line isn't the best, but the point is conveyed across. And we've labeled it R. Make sure that you do that as well. Now we also want to translate triangle S by the vector -4, -6, and we label it T. So -4, -6. So this is in terms of x, and this is in terms of y. If it's a negative, instead of going that way, we're going left. Because imagine you have a coordinate and you go -4, you're going left. Same thing for the y coordinate, okay? If it's -6, you're going down. If you add, you go up. So this is going left, and this is going down. How much by? It's going left by 4 and down by 6. So what we will do here is we'll get any point over here, and we'll go left. We'll go down by 6 first, so we go down by 3, down by 3. Then we go down over here by 4, so 1, 2, 3, 4. And this will be the new shape. Now we can just copy like the dimensions of the shape here immediately, and you get shape T. So a translation is just a movement, okay? But a reflection, you like copy it across, okay? You just find the flip version of it. So translation is a movement, and the x value is top and the y value is bottom. Okay, question 3. E equals n squared plus n plus 5. Ali thinks that the value of E will be a prime number for any whole number value of n. Is Ali correct? You must give a reason for your answer. When you see these and you say for any whole number will be a prime number, what you should do is you should immediately try just numbers. Okay, you want for your answer, you don't want to say, oh no, because some algebraic equation. No, just say let n equals 5, because he says for any whole number. So if you just find one example where he is wrong, you can write that and he'll be incorrect. Okay. So let's try 4. Okay. If we let n equals 4, you get e is equal to 16 plus 4 plus 5, which is equal to 25. 25 is not a prime number. And yes, we have proved them, but now we have to say, is he right or wrong? He's wrong. So he is wrong. Or she, I don't know, but see name. Anyways, question 4. ABC and DEF are parallel lines. BG equals BE. Angle DEG equals 38 and angle GEB is 65. They've been annotated. And you want to find the size of angle ABG. A lot of information has been conveyed at us, and there's a confusing diagram, and you're confused. So what we'll do first is we'll label the angle we want to find as x, right? Don't get confused. We just want to keep on track and make sure we're not losing focus on which angles we're trying to find. So ABG is over here, and we can call this x. We want to find this angle. Okay, let's begin. So first, notice that we have an isosceles triangle. Okay, how can we tell this? Well, look at this. We have these two lines, and they tell us it's an isosceles triangle. And what this will mean is that the bases will be the same. So this is also 65. And let's find this angle over here. Okay, 180 minus 65 times 2, which is 130, is equal to 50. So this angle is 50. Okay, because of isosceles triangle. Now, when you have these parallel lines, you might know the C like the C rule. So if I just draw a line here, here, and here, we have C rule. Okay, and what this means is that these two angles here and here will sum to 180. So let's see which angles we have. This is known as the co-interior. Okay, co-interior angles all sum to 180. So we have 38 plus 65 plus 50 plus x, which is the angle we're looking for, is equal to 180. Okay, that makes sense. All of these angles should sum to 180. Let's start adding things up. 38 plus 65, that's equal to 95 plus 8, which is 103, plus 50 plus x equals 180. Add these together, 153 plus x equals 180. And then subtract them. So we can just do side working here. I can't do this really in my head, so that'll be 7, 1, 7, 2, 0. 27 degrees. X equals 27 degrees. Okay, that's your answer. So we found this angle here by co-interior by isosceles triangle, because angles and triangles sum up to 180. And then we have this co-interior rule, which is where the question is different from a normal question. Okay, so in co-interior, these two angles, as I labeled earlier, sum to 180. You can write an equation for that and solve. Question number 5. Here are the first 5 terms in an arithmetic sequence. Okay, or first 4 terms, sorry, misread. Find an expression in terms of n for the n term of the sequence. Okay, so here is the step I would do, and here's what it means. An arithmetic sequence increases by the same amount each time from a starting value. What does this mean? Let's look at this sequence. We have 4. We have 4. We have 4. Okay? Every single time that the next term or the next number increases by 4. Okay? But it does not start from 0. Okay? But where does it start from? Well, it starts from 2. Okay? If this is the first term, the 0th term would have to be 2 because you add on to get 4. Hopefully that makes sense. So another way to do it is notice the difference is 4. So there'll be 4n. If you make n equals 1, you get 4. But we want to get 6. So how can you do that? We have to add 2. And that will give us our answer. So you can view it however you want. But yeah, find the difference, and that will be the coefficient of the n, the number in front. And then you have to add because it does not start from 0. Clearly, if you're 6 and it increases by 4, if you go backwards by 4, we get to 2, and that will be our little offset. And now we want to write down an expression in terms of n for the n plus 1 term of the sequence. What does this mean? Well, let's just plug in n plus 1. That's it. That's all we have to do. Okay. If we want to find this term of the sequence, we just plug it in. So 4n plus 1 plus 2 is equal to 4n plus 6. There you go. Next, question 6a. Simplify fully 20x squared y to the power of 6 over 4x squared y squared. So immediately we can divide by 4. We can get rid of the 4 here because you know 20 is equal to 5 times 4. So this will equal 5x squared y6 y6 over the 4's cancelled over x squared y squared. Now when we divide powers, it's important to know that we subtract. Okay, so look at this x squared and x squared. They're the same thing, so we just cancel it out. We're left with 5y6 over y squared. Because we're dividing y6 over y2, we are subtracting 2 from that power of 6 to get 5y4. Okay. Part B. Make E the subject of the formula in 3e plus f. Okay, so let's first isolate everything that has an e on the right side. So we have a plus f here, but we want to just isolate the e. So if you have plus f, to get rid of it, we subtract f on both sides. So you get h minus f is equal to 3e. And then we have 3 times e. We want to get rid of the times 3, so we have to divide by 3. We're doing the opposite. And make sure it's not just over just this one, it's over the whole thing. So it'll be h minus f over 3, the whole thing, is equal to e, and that will be your answer. Next, we have 2 quick questions here. So here is how you do standard form for large numbers. First, write out every single number until you get to the last non-zero number, okay? So in this case, the last non-zero number is 9. So write them all out, okay? 1, 3, 9. Okay, we've written them out. Okay, add a decimal point after the first one. After the first number digit, add a decimal point. Then you do times 10, and then count how many digits or how many different numbers there are after the first number. There are 6, so it's 10 to the power of 6. Okay, nice. Let's do this one. Write this in standard form. So first, let's start by writing every single non-zero number. So if we have 5, so if it was like 5 on 2, we write 5 on 2, you know? So you have 5 here. Okay, next, we don't have any other numbers, so it's just 5 times by 10. And you're probably thinking, what is it? Well, there's 3 zeros, so it's 10 to the minus 3. Okay, it's minus because you're going the other way. Instead of bigger, making it smaller, so it's minus. Question number 8. So we have to solve that simultaneous equation, and we have to show clear algebraic working. So solving simultaneous equations means we have to figure out some x and y value that makes both equations work. Okay, so how can we do this? Well, let's make the coefficient of either x or y the same. By that I mean let's make the big number the same. So it could be 4 and minus 4, which we will do, and that will work. Okay, it could be minus 4 and minus 4, that can also work. But just make that number the same. So how can you make it go from 2 to 4? Well, we can do that by timesing by 2. So let's do that. So if you times this top equation by 2, we get 6x plus 4y is equal to 30. And we get 10x minus 4y is equal to 2. Now, let's combine these equations. But notice, if we add them together, these two plus 4 minus 4y will cancel each other out, and we'll be left with just x. So let's add these together. We get 16x equals 32, because these two have cancelled out. Now we have a simple equation where we can divide by 16 and get x equals 2. We just put that there. But now we need to figure out y. So let's plug x equals 2 back in the first equation. We have 3, 2 plus 2y equals 15. Then we have 6 plus 2y equals 15. Then we have 2y equals 9, and if we divide by 2, we get y equals 4.5, and we can put that as our answer. Let's go on to question number 9. ACD are points on a circle, center O, AB and CB are tangents to the circle, angle ABC equals 74 degrees. Work out the size of angle ADC. So if you remember what I said at the beginning, make sure you figure out what angle you're looking for and just call x. Okay, great. Here's what you do next. So in order to figure out this angle, this will be double it. If you know that circle theorem, where the angle at the circumference is double the angle at the angle at the center is double the angle at the circumference. Okay. If you don't know that, what it means is that this angle here, which I'll mark in blue, so this angle is 2 times bigger than this angle, which is at the circumference. Okay. So try like kind of spot that arrowhead shape. It kind of looks like an arrowhead. So you have like an arrowhead. Like if you have a mouse pointer, it kind of looks like that shape. It might be a bit skewed, but that's a good sign. So notice that this will be double. So what else can we do? If we draw a line that cuts this shape in half, this angle will now be 37 degrees. And also remember the tangent meets the circle at 90 degrees. Okay, so tangent meets circle. So angle OCB equal 90 degrees. Okay. Whenever you have questions about circle theorems, it's always important to write down the theorem because while yes, you find the angle, you also have to write the theorem you found the angle with in order to get that second mark. Okay. But now we have that, and we have two angles of the triangle, and in order to figure out that angle, let's just do 180 minus 90 minus 37, which will be 90. And this angle will be 40, it would be 53 degrees. Okay. 53 degrees. And because we cut this shape in half, okay, because this shape is cut in half, what this means is that this will be 53 degrees, okay? So, angle at center double angle at circumference. What this means is that this angle, which is 106, will be double the angle that we're looking for at the circumference, okay? So from the circumference is the edge of the circle. So if we divide this by 2, we get 53 degrees, and that'll be our answer. Next, each month, Edna spends all her income on rent, on travel, and on other living expenses. She spends 1/3 of her income on rent. She spends 1/5 of her income on travel. She spends $420 of her income on other living expenses. Okay? So, let's figure out her income each month. Okay. So, here's how we're going to do it. If she spends 1/3 of her income on rent and 1/5 on in travel and the rest on living expenses, we can figure out what fraction, what fraction of her salary does she spend on the living expenses, okay? So let's do that. Let's add 1/3 plus 1/5. And if we do that, we get 8/15s. Okay, let me just quickly change my settings. Sorry, data display. I'm trying to find that date. Okay. There you go. So we have 8/15ths. This is how much this is how much she spends on travel and rent. If she spends the rest on her income, that means 7/15ths is spent on other living expenses. Sorry, 7/15ths is spent on other living expenses. Okay. So what does that 7/15ths mean? Well, it means that 7/15ths is equal to $420. So what is 1/15th? Well, we can divide by 7. 1/15 is equal to 60. So if you times 60 by 15, that's equal to 300 plus 60, which means 900 is the total she has an income. Question 11, work out that. Okay, so when you see these weird power equations with some variables. You want to try put everything to the same base power. So let's do that. Okay, so we have 2 to the x. That's the base. Base is 2. That's the smallest we can get. Notice that 4 is 2 squared. Okay, so if I write that as 2 squared and then 2x times by 2x, we now have it on the same base number, which is 2. And 128 is equal to 2 to the power of 7. Okay, so whenever we have brackets and we have powers here as well, what this means is that we need to multiply them, okay? So when you have it through brackets, we should multiply. The 2 to the 7 is equal to 2 to 4x times by 2 to the x. And what this also will mean is when we have times, we have to add the powers. So 2 to the 7 is equal to 2 to the 5x, because 4x plus x is 5x. And now what this means is because they're the same base, 7 equals 5x, so x is equal to 7 over 5. Okay, 7 over 5. And as a fraction, that is 1.4. Okay, now we have some more quickfire questions. Let's do this. So when we have this cubed, basically we're just cubing each part. So 2 cubed is 8. Now remember, when we have brackets, we multiply. So e squared times 3 is e to 6, and f3 times 3 is f9. Okay. Next, let's expand this part. So let's multiply each part. So we have 3x squared. And then we have 9xy. Then we have minus 4xy. And then we have minus 12y squared. And if we simplify this, we have 3x squared minus 12y squared. And then plus 5xy. Next, root a times a can be written in the form a root k, find the value of k. So whenever we have a root, yeah, that is just a fractional power. So root of a is equal to a to the 1/2. And if it was cube root, for example, it'd be a to the 1/3. And you can see if it's fourth, it'd be 1/4 and so on. Okay, so what this will mean is that we have a to the 1/2 times by a to the 1, because a, nothing should change 1, over a minus 2. So when we multiply, we have to add the powers. So we have a 0.5 plus 1 is 1.5. And as a fraction, that's, we could just leave it as 1.5 actually, over a to the minus 2. When we divide, what this means is we have to subtract the powers. So we have a 1.5 minus 2, so we're adding. So you get 3.5. And that is the k, because that's what we're looking for. Next, simplify 2n minus 1 to 4n minus 1. Okay. So notice that 4 is a square number. Okay, and so is 1. And this causes a difference of 2 squares. Okay, and difference of 2 squares is in the form of a plus b and a minus b, where a and b are the roots of their respective term. So let's do it. So the root of 4 to the power of n is 2n. Okay, and and the root of 1 is 1, so plus 1. And we do 2 to the power of n minus 1. And notice we have the same term, so we have 1 over 2n plus 1. Question 13. There are 2 bags of counters, bag X and bag Y. There are 20 counters in bag X, 11 of the counters are blue and the rest are red. There are 60 counters in bag Y, 9 of the counters are blue and the rest are red. We need to complete the tree diagram. So if 11 counters are blue out of 20, that means the other 9 must be red. So 9 out of 20 total counters are red. And next, in order to complete it, we just draw out our tree here. And there are 16 counters, and 9 of them are blue and the rest are red. So let's just label this blue and red to show the different outcomes, blue and red. And it'll be the same for each time. Okay, it's the same. So out of 16, we can do this because there are 16 total. So out of 16, there are 9 blue. So for blue, put 9. There's 9 blue, there must be 7 left for the others. That's the tree diagram completed. Okay. Work out the probability that both the two counters are red. So let's trace a path where both are red. So if we see this, we have boom, and we can go again, boom. So every time we trace the path, we are multiplying. We're not going through the path. At each step, we reach a fraction, we multiply. So let's multiply the fractions we went through. We went through 9/20ths, and then at the bottom, we went through 7/16ths. Okay. And what this means is we can just do 63 over 320. Now the posse is work out the probability that two counters are both red or are both blue. So what paths can we take? Okay, I'm going to use green for this. So we have to make sure that they are both red or both blue. So if you go both blue, we have to go here and take this path. Both blue, we have 11/20ths because that's the first fraction, and we multiply by 9/16. We take a blue and we have to take another one. That gives us 99 over 320. We know that both red is 63 over 320. Okay. Now, when we add these together, we get 162 over 320, which is our answer. Because we have to add these instead of multiplying because they are two different outcomes. You can't have them both happen at the same time. You can't both pass and fail a test at the same time. They're two different things. So we have to add them. Question 14. The table gives information about the areas and hectares of some farms in Spain. Irrelevant information. This is a histogram. Histograms can be really nasty and they require a bit of, working out. Okay, let's go. So, the frequency density is equal to the frequency over the class width. Okay. That's the formula you need to know. So if I write this a bit, just moved. Basically, the area, which is the frequency, because histograms, how they work is the amount is equal to the area of the given rectangle. Okay. So frequency is the area over the class width would give us the height. Okay. Because if you divide the area by the width, we'd also get the height. Makes sense. So let's do that for each one here. Okay. The class width is 20 because it's 20 divided by 40 will give us 2. This is 30 because this is 50 minus 20 is 30. 90 divided by 30 is 3. 50 here, and we have 140. 140 divided by 15 is equal to 2.8. Once again, we have 200 over 140 again. So 140 divided by 200 is 0.7. Okay, you can figure these out on your own. So for example, 140 over 200, you cross that out. 14 over 20ths is equal to 0.7 because you times by 5 to get 70 over 100, which is 0.7. Okay, anyways. Finally, 40 over 50 is 0.8. Now we have the frequency density. We just plot that here. So between 0 and 20, which is here, we need to go to 2. Okay. Between 20 and 50, so at 50, we need to go up to 3, which is over here. Okay, so let's draw in the boxes here. Between 50 and 100, we have to go to 2.8, which is just 2 less here. Of course, you should use your ruler when you're drawing boxes. And between 100 to 300, we go to 0.7, which is 3 less than here. And then between 400 to 350, we go to 0.8, which is here. Nice. That's your histogram drawn. Now remember, you should always try to find the frequency density. Remember this formula really, but remember that every triangle, every rectangle's area is known as the frequency, okay? And you can just find the frequency density with this formula. The class width is how big that class is. So over here is 20, then it's 30, then it's 50, 250. Hopefully you can see how you get to those answers. From there, you figure out the y value, and then you plot it. So between 0 and 20, the height will be 2. between 20 and 50, the height will be 3, and so on. Okay, and make sure you join them all up and they're all touching. That's very key as well. Question 15. Use algebra to show that is equal to 24 over 55. So the way you're going to do this is I'll let r equals 0.436 recurring. Okay. 10r be equal to 4.36 recurring. Makes sense. Now we want to get rid of this recurring decimal. So in order to get another complete, make sure that any decimals is recurring, we have to get rid of these two and move them. So we have to times by 100 to get 436.36 recurring. Now we can subtract them and this should get rid of the recurring decimal. 1000r, 10r, and then you just put equals 436.36, and then we just have 4.36. Bam. And take that out, we get 432, and then we get r equals 432 over 240. No, not 240, sorry, 990. Now, in order to go from 990 to 55, we can just keep simplifying. So let's first just divide by how can we get from here to there? Okay. We just divide, you can put can divide into, I won't necessarily go into that just to be a bit more official other questions. But you find the fact the number that divides to get yourself 24, it's not on top of my head right now. To get, it's not on top of my head, so I don't know. But that should get you the general marks, okay? That does seem to get you the marks using the mark scheme. It does show the marks to be there. One for calling setting the whole equation, and then the other one for getting the fraction. So this can be expressed in the form root a, where a is an integer. Okay, so first let's simplify the surds. What this means is, let's break them down. So root 20 is root 4 times root 5. And root 80 is root 16 times by root 5. And then root 3 is root 3. Notice root 16 is 4 and root 4 is 2, so we have 2 root 5 plus 4 root 5 over root 3. And then over here we can add these root 5s together to get 6 root 5 over root 3. And then if we times by root 3 at the bottom, we can get rid of it, and we get 6 root 15 because the surd multiply. And we get 3 to get 2 root 15. So when you multiply root 5 times root 3, it just gets added onto the surd. That will be your answer, I think. Oh yeah, and actually, hold on. It says it can be expressed in the form of root a, where a is an integer. So we need to convert this into one single surd. So if we make root 2 is equal to root 4, and then times 15, and if you multiply them, like I said, the surds combine, then we get root 60. There you go. That will be your answer. Okay, two functions are defined as follows. This is 4 marks. F of x makes 1 plus 1 over x for x is greater than 0, because x cannot be 0, otherwise that's undefined. And then g of x is x plus 1 over 2. Given that h equals f of g, express the inverse h minus 1 in the form h minus 1 x blah blah. Let's figure out what fg is. So if we have f g of x, what this means is we plug in this into that function. So let's do that. 1 plus 1 over x plus 1 over 2. Okay. Now what this is over here, I'm just going to do it. 1 divided by x plus 1 over 2. Keep flip change, we get 2 over x plus 1. Okay. We have 2 over x plus 1. And then we have to add 1. So that's what it is. So f g of x is equal to 2 x plus 1 plus 1. There you go. and then plus 1 at the top. So hopefully you can see how we got that there by doing flip change and then there. However, we're looking for the inverse. So let's look for the inverse of this function. The way we do that is we set x equal to 2 over y plus 1 plus 1. So the method for inverse is to make any x's y, and then make x equal to that whatever equation you have. And now we want to put y all by itself. So how can we do that? First, let's take away 1. Okay? Let's take away 1. X minus 1 is equal to that. Now that's equal to 2 over y plus 1. Here's what we do next. This might seem a bit tricky, but I hope you can understand. If we times by y plus 1, we get x minus 1. Y plus 1 is equal to 2. Now, we want to get y by itself, so we need to get rid of this. No, by getting rid of it, we divide. So y plus 1 is equal to 2 over x minus 1. And now we can subtract 1 to get y by itself. And that will be your answer, so we just write that here. Do not write y equals, you will lose marks, trust me. Just write the right side of the equation. Okay. Let's go through question 17. On the graph, here's a graph of y equals f of x, and then we want to draw 2 plus f of x. So what does 2 plus f of x mean? F of x, so y equals f of x, that means every y value is equal to f of x. Okay? So what this means is for every y value, we just add 2. So if you look at this, we go 3. This new value would be 5. If we look at this one over here, this new value would be 1. Which reminds me of the same thing. And now we have 3 points, and we can just connect them here. So what this plus 2 means is that we just move up by 2. Okay, now let's look at this one. The same graph again, and we want to draw y equals f minus x. What does this mean? Well, let's look at 1. If you look at 1, when x is 1, y is 3. Okay? However, let's plug in 1. How can we get f of minus x equal to f of 1? Notice if we make x equals to minus 1, we get f as 1. So if you look at minus 1, f of minus 1 would be f minus minus 1, which is 1. And what is the value at 1 is 3. That makes sense. Let's look at 2. If we plug in 2 as x, we get f minus 2. What is the value at minus 2? It's minus 1. That's the y value, so we plug that in there. Let's try minus 4. Okay? So at minus 4, when we plug that in, f of minus minus 4 is f of 4. What is the value at f of 4? It is minus 1. So f of f4, whatever, it's just a y value at that x coordinate. And now we have a new shape, and we draw. Notice how it's flipped along the y-axis, okay? So when the negative is inside the brackets, it's flipped along the y-axis, okay? If it's outside, it's on the x-axis. Question 18, which is the last one. I will also do the last one as well, but that one's very hard. You can stop watching afterwards and hope you've enjoyed from that. But let's solve this question. Show that this is that. Okay, let's just expand. So we have x minus 1 and x plus 1. If you remember from earlier, this looks like difference of 2 squares. So if you write it out in that form, we just square this side and square that side. Take away, okay? Hope you can see that. Now we can just multiply each side by x. So that would be x cubed minus x, because we just take factor out. Just multiply x there, and that'll give us the answer here. And now we have b. Prove that the difference between a whole number and the cube of this number is always a multiple of 6. Okay. So we need to prove that the difference between a whole number and a cube number is always a multiple of 6. Okay? Okay. Let's prove this answer. How do we do this? Well, a whole number, or one of the numbers, A is a multiple of 2. Why? Well, let's say we have an odd number. If an odd times an odd times an odd makes an odd, okay? But when you subtract two odds, it will get a multiple of 2. So you can see where that's going to come from. And if it's even logic, you know. And one of the numbers is a multiple of 3. So because it's a multiple of 2 and 3, 2 times 3 is 6. So it's a multiple of 6. Notice this, okay? Notice this. If x is a multiple of 3, then -1 will make a multiple of 2, or +1 would also make a multiple of 2. Okay, one of these has to be multiple of 2, because if we have 1, 2, 3, we notice we have 2 and a 3. If you have any 3 consecutive numbers, one of them will be a multiple of 2, and one of them will be a multiple of 3. So it's always a multiple of 6. 80 questions. Thank you for watching. If you want to watch the last one, please do. I would say it's probably an A-level question, really, because it's not even AS level. But let's go. Work out the sum of multiples of 3 between 1 and 1,000. Okay, so basically what this means is let's write out the first one. So you have 3, 6, 9, and then we do dot, dot, dot. And the last one would be 999, 996, 993. Okay. Now I want you to see an interesting pattern. We have 3 and 999. What do these add to? These add to 1,002. Okay, so now we go -3, but we go +3. So the sum has not changed, okay? It's not changed at all. It's just gone -3 and +3, which is the same. So we have another 1,002. Okay. Let's double this. Okay, let's double the answer it would be. Okay, so what this means is if you go back, by doubling, let's put it in reverse as well. So this is not GCSE, please don't pay attention, but this is how, I forgot who came up with this, but this is how they did it, okay? So they just reversed it. Okay, 993. And so on. All the way until you get 9, 6, 3. These are all multiples of 3. Okay, and notice how they all add up to the same thing because you go +3, -3, so the sum never changes. Okay, now how many of these occurrences do we have? Well, 3 is the first multiple, so 3 equals first multiple. And 999 is the 333rd multiple. I want you to notice that. That means we have 333 occurrences of this like sum, okay? That means that 333 times we will be adding these values. So let's do that. 333 times by this sum is 1002. Okay, 1002. But we also have to divide by 2 because we have doubled the amount of numbers we're using. Is equal to our answer. And this will give us an answer of, I'm not going to do it, I mean, it's not a GCSE option, it's optional question, so I'm just going to tell you 160,833. That's how you do it. I kind of showed you logic there, and that is enough to get the marks. Okay. Now, thank you everyone for watching. That was the whole paper completed, every single question, and I hope you have a good day.